Okay, today we are solving this problem called product of array except self. This is quite an interesting problem because even though it looks easy at first, coming up with the algorithm to solve this problem isn't exactly the most straightforward. So the idea of this problem is to basically multiply all the numbers except for the number at the index and then return the products. So for the first index, you want to multiply 2, 3, and 4. So 6 times 4, you get 24. And then for this one, you multiply 1, 3, and 4, you get 12. And for 3, you multiply, for the index at 3, you multiply 4, 2, and 1, that gives you 8. And for the last one, that gives you 6. So yeah, so how you go about solving this problem, one way of doing it is definitely just to first, basically you want the cumulative product to the left of the index, and then you want to calculate the cumulative product of the right of the index, and then you just multiply them together. So that is the idea basically. So let's start with the first part of getting the cumulative product to the left of the index. So for resulting product, let's call it that. Okay, so we initialize a resulting product variable, and the count will be basically the number of integers, and we initialize everything to 1. So let's begin by getting the cumulative product to the left of the index. So for I in 1 to num.count, we want the cumulative product to the left. So do I minus 1. Then we multiply this by I minus 1. Okay. And let's look at what we get here. So this is the first part. Okay, so you get 1, 1, 2, and 6. So that is everything cumulative product to the left of the index. So which is why you see the last index you already have the answer, but it's only for the last index. But now you just need to go from the right to the left and multiply all the cumulative product from the right. So let's go ahead and do that. So we can keep track of a running product to achieve this. And count. Can reverse this. Okay, so we want the item at the current index to equal to basically the current product times the running product, and then you can set the running product to the number at this index for the next iteration. And this should give us the result. Okay, so there you have it. The time complexity is linear time. You loop basically forward and backward 2 times, and the space complexity is, well, if you count for the resulting product, it will be linear space. But if you discount the resulting product, as just simply an auxiliary array, you can say that this is a constant space solution. And that's it.